7.5. Solving quadratic equations by factoring. Let's take a look at an example involving a difference of squares. Determine the roots of the following equation. 75p squared minus 192 is equal to 0. I can see right away that I have a common factor of 3, so I'm going to divide all of this by 3. On both sides, of course, to maintain equality. This works out to 25p squared minus 64 is equal to 0. Then I see that I have two perfect squares. I can take the square root of both of them. That means that my factors are going to be 5p minus 8 and 5p plus 8. I'm looking for the roots, and I know that if I set these to 0 and isolate p, I will get the roots. So 5p minus 8 is equal to 0, and 5p plus 8 is equal to 0. I can then isolate p, and I get p is equal to 8 over 5, and p is equal to negative 8 over 5. So the roots are 8 over 5 and negative 8 over 5. Let's verify using a different method. It's pretty easy. So I had 75p squared minus 192 is equal to 0. What happens if instead of factoring, I move 192 over and do algebra? 75p squared is equal to 192. I'm going to divide by 75 on both sides. That yields p squared to be 64 over 25. Then I need to take the square root of both sides. P is equal to plus or minus, the root of 64 is 8, over the root of 25 is 5. So P is equal to plus or minus 8 over 5, so this is correct. Let's do another example. Using reasoning to write an equation from its roots. Tori says she solved the quadratic equation by graphing. She says the roots were 5 and 7. How can you determine an equation she might have solved? So the roots were negative 5 and negative 7. I'm going to write that as x equals negative 5 and x equals 7. Then I'm going to move the negative 5 and the 7 over to get an expression that is equal to 0. So if I add 5 to both sides, I get x plus 5 is equal to 0. If I subtract 7 from both sides, I get x minus 7 is equal to 0. So one factor is x plus 5, the other factor is x plus 7. I can write those like this. Then I can use the distributive property and multiply this out to get x squared plus 5x minus 7x minus 35 is equal to 0. I can then simplify my expression. X squared minus 2x minus 35 is equal to 0. So a possible equation that she might have solved would be x squared minus 2x minus 35. Example 5. Describing errors in a solution. Matthew solved the quadratic equation as shown. Identify and correct the error in Matthew's solution. If we take a look, Matthew made an error in this second line. He divided both sides by x, so he eliminated a possible factor. He eliminated a possible factor x equals 0. Because remember, we can never divide by 0. Let's correctly solve this equation. 4x squared minus 9x is equal to 0. I'm going to factor out an x. 4x minus 9 is equal to 0. So here I have x is equal to 0, that's one factor, and I can set the other one to 0 as well. 4x minus 9 is equal to 0. Then I can isolate x on my right-hand side on this one. Isolating x, I get 4x is equal to 9. X is equal to, if I plug that into my calculator, divide by 4 on both sides, 2.25. Let's verify my zeros. So, for x is equal to 0, that's one of my roots. Let's do the left side and a right side chart. My left side is going to be 4 times 0 squared minus 9 times 0. Well, that's going to be 0. And my right side is already 0. So this works. What about for x is equal to 2.25? Let's check and see if this works. So I have my left side and my right side. My right side is equal to 0. My left side will be 4 times 2.25 squared minus 9 times 2.25. If I plug that into my calculator, I get 20.25 minus 20.25, which is equal to 0. So that one checks out as well. In summary, some quadratic equations can be solved by factoring. You need to know, in order to factor an equation, start by writing the equation in standard form. You can set each factor equal to 0 and solve the linear equations. Each solution is a solution to the original equation. If the two roots of a quadratic equation are equal, then the quadratic equation is said to have one solution.